Hello everyone, welcome to today's lesson. This begins on page 5 in your notes, and this topic is called function notation. It's just a different way that you can write the equation of a function. So for example, what if you had a function such as, let me just put down a very simple linear function here, y equals 2x plus 3. Okay, like I say, it's a very simple linear function. It definitely is a function. If you were to graph that, you would clearly see that it passes the vertical line test. And also you could ask yourself, if I put in a certain x value there, any number whatsoever for the independent variable, how many different y values would I get back? And of course, the answer would be just one. So it's definitely a function. Now, if something is a function, there's another way that we can write this. Okay, we give the function a name, a letter. Usually the letter F is chosen. Okay, because F, of course, is the first letter in the word function. So what we would do is we would put down the F in front. We would replace the Y with F. And now you also put down a set of brackets after the F, and inside the brackets you would place whatever the independent variable is. Well, in our case, the independent variable is x. So I can rewrite this function like so. Now the 2x plus 3 part, that doesn't change. Okay, that does not change whatsoever. But this is a new way that you can write this function. Remember, f is just the name of it. You could have called it g of x or h of x or any letter really, but we decided to call it f. Now, the way we would say that, the way we read that, we pronounce that, it's called f of x. All right, f of x, just like it says right here. All right, in your notes. It's called f of x, but it really means just the same thing as y equals. There's nothing there different about that. Now, one common mistake students make when they look at this kind of a notation, they think that this means f multiplied by x, but that is not what it means. All right, it's just a different way of writing y equals. F is just the name of the function, and x in the brackets, that just means that our independent variable is x. Now, you could have functions that look like g of n, for example. So the name of the function would be g, and the variables now are not x's. The independent variables would be n. So it might be something like just g of n is equal to n squared, and we would call that g of n. All right, so it's just a simple way that you can write functions. Very simple idea. Now, here's where writing something in function notation makes a lot of sense. Let's look at example number 6. And again, this is on page 5. Let's look at part A. Here we're given a function. Everyone see that? F of x equals 2x plus 1. It means exactly the same thing as y equals 2x plus 1. All right, but they're calling it f, and the independent variable is x. Well, look at this little thing right here. What are they asking you to do there? Well, they're asking you to evaluate the function f when x is equal to 1. So what you do is you would actually put in 1 in place of x in your function, and you just work it out. You just evaluate it. It's like saying if x is equal to 1, what's the value of y? You've done that many times before. So here's how we write this. We say f of 1 is equal to, and now as soon as you write f of 1, then you have to replace all the x's, all the independent variables, in your function with a 1. And now you just work that out. You could use a calculator if you wanted to, but you wouldn't need a calculator for that, I hope. So that means that f of 1 is equal to 2 times 1 plus 3. All right, so there you go. It's like saying when x is equal to 1, y is equal to 3. And if you were to graph that function, by the way, now that you have an x value and a y value, well, you would have the point 1 comma 3 on that function. Okay, so that's all this means, everyone. It's really, really straightforward. The part B there, let's look at that one. What is t of x? Okay, so they're naming this function t, no big deal. The independent variable is x. All right, and I can see it's negative x squared minus 9. That's a function as well. Well, look at what they're asking you to evaluate here. They're saying take the function t, okay, and replace the x's, replace the independent variables with -3. So t of -3 in this case would just be negative. Now make sure you put -3 in the brackets, and that becomes squared minus 9. Now be careful there. That's not a negative negative. That does not become positive because remember, order of operations, you're supposed to square that first. All right, so this would become a negative. Now that just becomes 9, and then minus 9. So t of -3 is equal to -18. There you go. When x is -3, y is -18. That's all it means. All right. And for part C, that one is easy as well. Look at this. F of x is equal to 5. Now that's the same as y equals 5, remember? That's really just a horizontal line. So if they're saying evaluate the function f when x is equal to 9, all right, let's see. That means that wherever there's an x in that function, and it is a function, I have to replace the x with a 9. But there's nowhere to actually put the 9 because no matter what x value you have, you're always going to get back 5. So in this case, f of 9 is equal to 5. In fact, f of any real number would equal 5 in that case right there. So it's very simple, very straightforward. Function notation and evaluating a function for a value of the independent variable. Now here's some more examples here, practice number 6. I'm going to leave these for you to try. Most of them they're calling f. So here's f of x. Here's f of q is b. C is f of s. No big deal. You can see s is the independent variable there. And d, they're using f of x equals x squared plus 25. Now what is different about d, though, if you look at it carefully, look at what they're asking you to evaluate. Right? They're not telling you to put a number now in place of x. They're saying replace all the x's in the function f with x plus 1. So what you would have there, f of x plus 1. Now remember, you're not putting a number in. You're putting a different expression in. So here in brackets, there you go. You're squaring something and you're adding 25. That's what the function f does. It squares something and adds 25. Well, you actually put in x plus 1 there. And now you have to simplify this. You have to work this out. X plus 1 squared, remember, that's a binomial times itself. That's 4 multiplications, not 2. So x plus 1 multiplied by x plus 1 again. Be careful with that. And if you do your 4 multiplications here now, you'll get x squared plus 1x plus 1x. All right, well, that's plus 2x. And then plus 1 times plus 1 is plus 1 again. So this would become x squared plus 2x plus 1 plus 25. And now you add your like terms together, which in this case would just be the numbers. So you're going to end up with x squared plus 2x plus 26. Now notice, in this case, for D, you didn't get back just a number either, did you? Right? You got back, in fact, another function, a different function. And that usually is what happens whenever you replace the independent variable with some expression involving x. All right? So I'll leave the ones on page 2 for you to try. Now here you have a function f of x, you have another function g of x, and there's a third function h of x. Well, all you need to do is replace in part A, replace in the function f, replace your x with a 4. Well, that's easy enough. In the function g, this is part B now, replace the x with a -2. Well, that looks easy enough. And C and D are also relatively straightforward. Now notice for D, f of 2 is right next to g of 1. That is a multiplication. Okay, so you have to multiply those. But they're all relatively straightforward. Please make sure you check the solutions on D2L to make sure you're doing these correctly. But it's not that difficult of an idea, but it's an important idea. Now, one other thing I'd like to do in this lesson, and this is really easy as well. This is called reading values from a graph. And you've actually been doing that a long time now. All right. If you are given the graph of some function, like this function right here, for example, And if I were to tell you what a certain x value is, would you be able to determine what the y value is? Well, hopefully, yes, you would. Or sometimes I may even give you the y value and ask you to determine what the x value is. But it's really straightforward. So for example, number 7 here. All right, let's have a look at that. I don't know why they've got part A. There's no part B. But they're saying find f of 2. Now, that's the same thing as saying find y when x is equal to 2. All right, so you come over to your graph. And you look on your x-axis and you find out where 2 is. Well, there's 2 right there on your x-axis. What point on your graph has an x value of 2? Well, you have to go right straight up and ta-da, right there. You see that? They've got a hollow dot there, but that's the point where x is equal to 2. So at that point, what is your y value? Well, you just look straight across. You might have to look left, you might have to look right, but you find the y value for that point by looking straight across. And there it is. Look at that. I'm pretty sure that that is actually equal to 3. In other words, when x is equal to 2, y is equal to 3. Just like they're saying right there. Now, there's another practice one on the bottom of that page. And like it's just as simple. It's just as easy. Part A says, when x is equal to -1, what is the value of y? So you look carefully at your graph, and you find where -1 is on the x-axis, and right there, look at that. See that? There's your -1. So you look up or down, and you will find the point corresponding to x equals -1 on the graph. Well, I think in this case, we have to look straight up, straight up, straight up. Boom, right there. You see that? There's the point. Now, what's the y value of that point? Well, according to my old eye, it's not quite as high as 4. Now, if you said 4 on a test or a quiz, I'd probably give that to you. But to my old eye, it's kind of looks like it's a little bit less than 4. So if I said, like say 3.9, something like that, you're only estimating anyway. That's a pretty good estimation for what that y value is. All right, so and you just do the same thing with the other ones. B says when x is equal to 0, what is the y value? Now remember, you're only going to get one y value back if it's a function, that is, because remember, if it's a function, one value of x only returns one value of y. So you look that one up. What is y when x is equal to 0? C means what is y when x is equal to 4? All right, and they're relatively straightforward. You might have to estimate some of these, but sometimes you do not. Now, D is a little bit different, though, okay? D, they're not giving you the x value. In this case, the 2 is actually the y value. And you have to look carefully at your graph and find out, like, what is x? What is x when y is equal to 2? So you would locate 2 on your y-axis. Let me see, where's 2? Right there, look at that. See that? On the y-axis. And now you go left or right, in this case both, and you will hit the points on your graph, and there's one right there. Ta-da. And then you go to the right, and there's the other one. So there's actually 2 x values here. There is 2 answers. Remember now, that's okay, though, to be a function. If one x has to give you one y, but remember now that one y can give you different x's. So in this case, let me see, what do they look like? What do they look like? Well, the first one looks like it's about right there. That's about the x value. So I would call that maybe -0.4. It's 2 blocks out of 5. Yeah, -0.4. And the other one up here, well, what's that x value? Again, to my old eye, I would probably say +4.4. And that's how you read values from a graph. Very simple. You've been doing that now for a while anyway by looking at graphs. Okay? So I'll stop there. Time is almost up anyway. So try the extra practice questions above that now on the function notation. Check your answers on D2L and let me know if you have any trouble with anything. And that's it for today's lesson. Bye-bye.